Hello guys, so here I am with a VMware Windows 11 x64 machine. Um, I will show you a small thing now. If I start the machine, I have a UEFI driver which loads very early. It will actually exit without staying resident, but it will make itself resident by other means, not using any UEFI thing, or it will just make resident in memory uh, and establish some interrupts and some things there in order to act as a debugger both in this UEFI early stage and then in the Windows operating system loading phase, NTOS kernel loading phase, and then in the actual normal Windows operation, right? It will survive the operating system loading, uh, do a lot of things to spy on some critical parts of the operating system in order to be able to still draw to the screen and use the keyboard and mouse. Well, mouse is still a bit work in progress. So this is PS2, both for the keyboard and the mouse. However, I am now doing research on USB 3 XHCI controllers, right? And well, so this is like the very simple debugger interface. It's the background is black, but this is actually transparent. You will see later. Uh, we can do the normal things here. Again, this is work in progress, so still quite simplistic. We can, however, disable parts. Upper part is register. Window register will toggle that. Window data, which we can disable, enable, make it bigger, smaller. For example, window assembly. Let's disable the disassembly part, or we can, now we can also disable the data, but I will now make data quite bigger. For example, like this. Put a small disassembly here. For example, I don't know, 10 maybe, something like that. Yeah, we can do a lot of stuff. We can also move this with Control Alt and cursors, change sizes. There is plenty of things we can do. We have the lowest part is aligned with some useful information in order to externally debug the machine with the debugger. Then it has the command input. For example, I am passing instructions now. I will trace the instruction now. Things like that. These yellow parts are the symbolic information. It's data or disassembly. They have their own symbolic information. By the way, data can also be, for example, done in words, the words, quad words, whatever. Window data will be, for example, let's see. This is the base address of my USB 3 controller. Let's put this like, okay, doesn't fit. Well, let's disable this assembly, enable data, but with more lines, 20 for example. Windows assembly, I don't know, 18, whatever. So also I can use any selector I want for the data window. I can also use the pseudo selector called not a numeric one but phys, FH, as a PH, YS. This will be for dumping data physical addresses. Again, let me show you FE2 in this virtual machine. This will be the base address of my USB 3 controller, XHCI controller. I will dump it again as the words, which is 2. Now I can toggle and cycle the window, the cursor between windows, and we can navigate here. This is the something I am doing research on in the USB 3 controller. This is MMIO, uncatched, and yeah, this is physical addresses. So we can see the typical things here. For example, this will be the offset to the doorbells. This will be the offset to the, in this case, this is the offset to the command ring and device slots, which is 820. If we dump that again, dump FE200A20, which is the indicated slot information. And this is, the very first D word. If you see there, I am moving the mouse, by the way. If you see there, this is changing all the time because that's the microframe counter of the USB 3 controller. Do you see that? It's this one. We can edit things here also. And by the way, I am working on a contextual menu here to do following of the values, editing, writing back to the memory, maybe searching for symbolic info. But you can see there that there is an ever-changing counter. That's a 10-bit counter that's incrementing once every 125 microseconds. That's something every USB 3 controller has. Okay. Yeah. So anyway, this would be it. Let me continue execution now, and we will arrive where Windows logo. You see that Windows logo. As I said, this is transparent. Okay. This is transparent. But you can move, let's say, the window, and there is, you can see the logo there. Okay, so one thing you can check now is that if you see this small text in yellow there, it says NTOS kernel, NTOS krnl.exe, bang, entry. Entry is not an actual symbol, but it's the entry point of the PE file. This is the NTOS, the Windows NT kernel. And these are the very first instructions it does, okay? So let's pass some, trace some instructions here. You will see very soon after starting, it does the typical SGDT, SIDT, SLDT, LDMX the typical things to get the original places where some of these tables are, right? And then it will start to change them, install its own interrupts and all that, which the debugger intercepts, and let's say parasitical, it does some parasitic stuff in order to survive all these changes in memory layout and all that, which is quite a let's say esoteric thing to do. But so this is, you can see this. I can set breakpoints here. For example, I can do a here. It executes until that point. We can, for example, I don't know. We can put some. Let's try some instructions here. Yeah, these are the very first instructions of the NT-OS kernel. Okay. Um, for example, here we entered some function that is, well, no, it's actually some at some offset from that, but it will be HAL init system. Uh, some years ago, HAL would be in another DLL, another module. Some of the HAL functions have gone to NTOS kernel nowadays, but yeah, you can still see how it's executed. Let's trace some more instructions. Okay, I am tracing, as I press. Um, yeah. For example, here you can see more symbolic information, right? Um, these are memset, RTL run once initialize, yeah, some other stuff there. I pressed F9, so it's executing now. But yeah, so this is more or less what I wanted to show you. It's a lot of things are going on, work in progress. I have hook drivers for, well, parasitic drivers for the video part in order to be able to draw when the operating system is already loaded. Um, a lot of things going on with yeah, a lot of things. Right now, I think it will crash because I am hooking the timer interrupt for some stuff, and yeah, there is some issues here. But that's it, guys. I just wanted to show you a small demo of what I'm doing right now. Right now, trying to give support to USB 3 mice and keyboard, but in again in a parasitic fashion, as I do with the video, which is doing parasitic hookery to WDDM drivers, Windows display driver model, mini port drivers. There is another, a lot of things going on there, so to be able to follow what the actual GPU driver does in order to be able to draw, as I do here in the UEFI stage, but when the Windows is properly loaded, right? Well, I am trying to do the same for accessing the keyboard and mouse at a very, very low level and in a innocuous fashion, let's say, not not ruining actual normal execution of Windows when we are not in the debugger, right? And for that, you don't actually access the USB 3 or XHCCI hardware or controller. You have to do it in a non-intrusive fashion, right? That's why I say parasitic. And that's it. I know it's a bit of a heavy thing, but yeah. So this is a new recording software I never used before. So let's see if it works properly and I can upload this to YouTube and show it to you in case you are interested somehow. Okay, guys. Cheers. Bye.